Welcome to the channel, everyone. If you share a passion for discovery and want to be at the forefront of humanity's greatest breakthroughs, please hit that subscribe button right now and turn on notifications. By doing so, you're helping me bring you even more of these deep dive documentaries. Let's take a look at our own world. A lonely, fragile cradle on the edge of the cosmic dark. For generations, we have taken it for granted that the Earth lives, breathes, and provides us with a home. But the reality is, we have been traveling through space blindly. Now, as our latest space telescopes peer deeper than ever before into the heart of the Milky Way, the ancient question suddenly becomes a burning reality. Are we truly alone in this frozen infinity? Or is the darkness of the cosmos actually teeming with hidden oases just like our own, merely waiting to be found? Today we embark on an extraordinary journey. Leaving the safety of our solar system behind, we will count down the top 5 exoplanets most likely to harbour alien life. These worlds all orbit within the so-called habitable zone, also known as the Goldilocks zone. This is the magic region around a star where it is neither too hot nor too cold. A place where temperatures are just right for liquid water to exist on the surface. Because, as we know from life on Earth, where there is water, life finds a way. We will begin our journey with the most distant and mysterious giant, and conclude with the planet that awaits us practically right in our own backyard. 5. Kepler 22b, a realm of boundless oceans. The first stop on our journey, and number 5 on our list, is Kepler 22b. This planet is a true legend among astronomers, as it was the very first world discovered by NASA's Kepler space telescope in the habitable zone of a Sun-like star back in 2011. To grasp just how far that is, brace yourselves. It lies 4.5 trillion miles, or 635 light-years away from us, in the direction of the constellations Cygnus and Lyra. If we were to set off today in our fastest existing spacecraft, the journey would take millions of years. Kepler 22b is what we call a super-Earth. Its diameter is nearly twice, more precisely 2.5 times, that of Earth, meaning both its mass and gravity are significantly greater than ours. The most exciting thing about it is its star, Kepler 22, which is practically a twin to our own Sun, a G-type yellow dwarf, just a hair smaller and cooler. The planet orbits its star in 290 days, making its year remarkably similar to Earth's. But what would it be like to stand there? Well, chances are there is no solid ground to speak of. Based on density data, scientists believe Kepler 22b has no rocky surface. Instead, we are looking at a vast, all-enveloping global ocean, a water world with no shores and no continents. Thanks to its dense atmosphere, the average surface temperature is estimated to be a comfortable 22 degrees Celsius. If life exists on this planet, it must have evolved in the endless dark depths of the deep sea, far from any concept of dry land. But imagine just for a moment that a single tiny island emerges from this endless global ocean. A solitary piece of solid ground defying the waves. If Kepler 22b hides such a sanctuary, it wouldn't just be a rock in the middle of nowhere, it would be a true oasis of paradise. A place where starlight, liquid water and solid ground meet in perfect harmony. Such a discovery could easily propel this mysterious world to the very top of our list as humanity's most promising new home among the stars. 4. Trappist 1d, on the fragile edge of the Goldilocks zone. Trappist-1d is the third planet from its star, dancing right on the inner edge of the habitable zone. What we know for certain, thanks to the James Webb Space Telescope and ground-based observations, is that it is a true featherweight world. While it is a rocky planet like Earth, it is incredibly small, with a mass just 30% of our own. Because of this, its gravity is far gentler than that of the super-Earths we've seen so far. If you were to stand on its surface, you would feel barely half of your earthly weight, light, almost buoyant. But there is a massive mystery surrounding Trappist-1d, its density. According to measurements, this planet is simply too light to be made of pure rock. This could mean one of two things. Either it is wrapped in a thick, suffocating layer of gas like Venus, or something far more thrilling. Water. Massive amounts of water. Scientists estimate that water could make up as much as 5% of Trappist-1d's total mass. That is 250 times more water than we have on Earth combined. The faint reddish light of the central star barely pierces through the dense atmosphere. On this world, eternal twilight reigns supreme. Because the sunlight's intensity is only a fraction of what we experience on Earth, nature has found a radical answer to the lack of light. The unfamiliar vegetation blanketing the surface is a truly strange sight. While closer inspection reveals a vibrant array of colors hidden within the cells of individual specimens, the landscape remains mysterious and somber. As our eyes sweep across the horizon, the monumental forests stretching into infinity all boast a deep, dark hue. This dark foliage is the plant's only means to soak up the star's weak energy like a sponge. The canopies of the trees absorb almost every last drop of the remaining light. But life doesn't stop with the flora. Venture into these dark woods and the fauna remains hidden. In this dim world, survival depends on camouflage. The wildlife has adapted to the star's faint light, with creatures cloaked in dark or entirely black hues. They move like shadows within shadows, blending seamlessly into their surroundings. A world where colors are locked away, and the surface is ruled by creatures of the dark. This is Trappist-1d.
Kepler 442b ranks third on our top 5 list of potentially habitable exoplanets. Discovered by the Kepler Space Telescope, it's about 1.3 times the size of Earth and orbits in its star's habitable zone.
Continuing our journey into the deep cosmos, we arrive at number 4, Kepler 442b. Located some 1,200 light-years away in the constellation Lyra, this world remains beyond our reach for direct imaging. However, based on complex physical models, astronomers consider it one of the most promising candidates in the universe, not just habitable, but potentially superhabitable. What does superhabitable actually mean? Scientists suggest that Earth may not be the ultimate blueprint for life. Kepler 442b is slightly larger than our world, with 30% more mass and a 33% greater radius. This size is ideal. It's a rocky world, but its increased mass generates a stronger magnetic field, shielding the atmosphere far more effectively against lethal cosmic radiation. The planet orbits an orange dwarf star, Kepler 442, a favourite among astronomers. Why? While our Sun is expected to burn out after roughly 10 billion years, halfway through its life, orange dwarfs can shine steadily for up to 30 or even 50 billion years. This gives Kepler 442b vastly more time for life to emerge, evolve, and reach high levels of complexity. With an orbital period of 86 days, the planet receives just the right amount of energy to keep water liquid, neither boiling nor freezing. Plus, the light from its star is perfect for photosynthesis. If we could ever reach it, we might find a world even richer and more lush with life than our own. Kepler 442b's uniqueness isn't just about its star. The planet's dynamics create conditions hard to fathom by Earth standards. While axial tilt and lunar gravity cause constant climate fluctuations in our solar system, Kepler 442b's orbit and rotation likely produce a far more stable climate. This stability is key. Without the drastic temperature swings we experience on Earth, the planet may have evolved into one vast, perfectly balanced biosphere. Geological activity also plays a vital role in surface conditions. Due to its greater mass, the planet's core likely cools more slowly, meaning tectonic movements, such as plate motion and volcanism, remain intense. This constant planetary breathing ensures the chemical replenishment of the atmosphere, maintaining the carbon cycle, which is essential for regulating global temperatures and bringing nutrients to the surface that are indispensable for life. Stepping onto the surface, the landscape would feel profoundly alien. Because the light spectrum of the host star shifts toward the infrared, photosynthesis here has evolved along a drastically different path than our own. The vegetation is not green, but a deep, dark crimson, often bordering on black, allowing the flora to harvest every possible scrap of energy from the star's faint radiance. This red jungle stands in stark contrast to the seas. Due to the unique radiation environment and the specific cocktail of dissolved minerals, the oceans of Kepler 442b shimmer in a vibrant emerald green. It is a striking sight. The water's chemical makeup, its higher salinity, and the specialized microbial communities thriving in the dim light create this jewel-toned hue, providing a dramatic, vivid rupture to the vast monotony of the crimson continents. One must also consider the planet's atmospheric pressure. Models suggest that Kepler 442b possesses a significantly denser atmosphere than Earth's. This thicker layer of gases does more than just stabilize temperatures between the day and night sides. It fundamentally changes the physics of flight. For any indigenous life form, the increased density provides substantial lift, allowing massive creatures to take to the skies with ease, or remain aloft with far less effort than would be possible in our own thinner air. And perhaps one of the most fascinating and often overlooked aspects of its superhabitability is the planet's location within the galactic habitable zone. Kepler 442b doesn't reside in the crowded, radiation-drenched heart of our galaxy. Instead, it sits in a region where the stars are more spread out, and the risk of a nearby supernova or other catastrophic cosmic event is virtually non-existent. This cosmic tranquility has allowed for an uninterrupted evolutionary process, elevating the planet into a kind of galactic time capsule, a true sanctuary. While our current technology isn't yet advanced enough to detect chemical signatures, so-called biosignatures, in its atmosphere, the theoretical framework is already in place. Kepler 442b is a place where the laws of physics and biology may have converged in the most optimal way we have ever seen. This begs the question, just how likely is it that we're really looking at an oasis? According to astronomical models, Kepler 442b stands out as one of the strongest candidates for superhabitability. With an Earth Similarity Index, ESI, of 0.84, it boasts a value remarkably close to our own planet. While true certainty would require direct atmospheric measurements, the combination of its physical parameters, its rocky composition, its ideal orbital distance, and its substantial mass, leads researchers to estimate that there is a better than 70 to 80% probability of a habitable surface. This is far from mere speculation. The statistical likelihood that this world possesses the conditions necessary for life is among the highest of any exoplanet discovered to date. So how did we discover this distant world? The credit goes to NASA's Kepler Space Telescope, which employed the transit method, monitoring the subtle, rhythmic dips in a star's brightness as a planet passed across its face. In 2015, an international research team led by Andrew van der Berg identified the signal while analyzing data collected by Kepler. This discovery was a true milestone, confirming that planets with stable environments, much like our own, are not rare in our galaxy.
You're not afraid of me, are you? Here, try this. That's it. Gentle.
The biggest question, of course, is this: will we ever get a clear look at this world? At a distance of nearly 1,200 light-years, the journey is currently an insurmountable obstacle for traditional space probes. With today's rocket technology, it would take millions of years to get there. However, the future of observation is bright. Next-generation space telescopes, the successors to the James Webb or future high-powered interferometers, could be capable of performing a spectral analysis of the light filtering through the planet's atmosphere. This process, known as spectroscopy, will allow us to measure its chemical composition. If we detect molecules like oxygen, methane, or water vapor, and in ratios that can't be explained by geological processes alone, we will have direct evidence that the emerald oceans and crimson jungles of Kepler 442b are not merely products of our imagination, but the components of a living, breathing world. While our current technology isn't yet advanced enough to image the continents on its surface, for the first time in human history, we have moved beyond simply asking, "Is anyone out there?" We can now actively search for the answer on a world that, by all accounts, appears ready to embrace life. Trappist 1e is the planet astronomers are focusing on most when searching for signs of extraterrestrial life. And there's a good reason for it. Its size is almost identical to Earth's, with a radius 92% of our own. But what's even better is that its gravity is almost exactly what we're used to. If we were to land on its surface, our legs would carry us forward with the same ease as they do back home. According to data from the James Webb Space Telescope, the planet has a solid, rocky surface and, most importantly, a stable, temperate climate. This world isn't steaming like its inner sibling, nor is it a frozen snowball. Liquid water can remain stable on its surface, forming vast, surging oceans and continents. Earthly green would have no chance here. Due to the weak radiation of the red dwarf, which consists mainly of infrared light, the local flora must absorb almost every visible wavelength of light, utilizing the blue and red ranges most aggressively. Evolution has painted this landscape with a breathtaking brushstroke. The hills, valleys and forests of Trappist 1 are not covered in green grass and trees, but in a continuous, mysterious, dark purple vegetation. Imagine endless purple fields and monumental tree-like organisms with leaves and trunks ranging in color from a deep velvety violet to an almost black eggplant shade. As the gentle alien breeze stirs this dark purple wilderness under the orange sky, the sight is simultaneously soothing and haunting. TRAPPIST-1e is a true twin-planet world. Familiar physics, friendly gravity, but with a completely rewritten color palette. A dark purple oasis that reminds us life can find a way anywhere. It just dresses reality in its own otherworldly colors. TRAPPIST-1e. We are just 40 light-years away from Earth, in the direction of the Aquarius constellation. TRAPPIST-1 is an extraordinary system, an ultra-cool red dwarf orbited by 7 rocky planets, nearly identical in size to Earth, packed incredibly close together. Among these 7 siblings, the 4th one, TRAPPIST-1e, is the crown jewel of the system. In terms of size, it is almost an Earth twin. Its diameter is 91% of our own. Why is it the most promising of the 7? Because it lies dead center in the middle of the habitable zone. Calculations suggest that TRAPPIST-1e receives almost exactly the same amount of energy and heat from its star as Earth does from the Sun. This means that its temperature conditions could be extremely temperate and friendly. Because the planets orbit so closely to one another, if you were standing on the surface of TRAPPIST-1e, the neighboring planets wouldn't just look like tiny pinpricks of light, like Mars or Venus do from Earth, but would appear as massive, detailed disks, even larger than our Moon. This planet is currently the primary target for the James Webb Space Telescope. Scientists are actively analyzing its light as it transits its star to determine the composition of its atmosphere. If they detect a combination of oxygen, ozone, carbon dioxide, and methane, it will be irrefutable proof that a biosphere currently exists on TRAPPIST-1e. How did we discover it? In 2017, NASA researchers made a dramatic announcement. Using the Spitzer Space Telescope, along with ground-based observatories, an international team of astronomers working under the Trappist project observed tiny dips in the star's light. These transits revealed the existence of the planets. Whenever a planet passed in front of its star, it blocked a portion of its light. And that is how we discovered TRAPPIST-1e, a world that may be the most Earth-like of them all. Could it be habitable? For scientists, TRAPPIST-1e is considered the Holy Grail. It orbits within the star's so-called habitable zone, that narrow band where temperatures are just right for liquid water to exist on the surface. According to our models, this planet is the system's most promising candidate for life. Although its host star is a red dwarf that occasionally bombards its surroundings with intense flares, TRAPPIST-1e sits at just the right distance for its atmosphere to protect the surface and potentially harbour life. However, this world is vastly different from our own. Due to immense gravitational forces, the planet is likely tidally locked. This means it perpetually shows the same side to its star. On one hemisphere, the crimson sun never sets, while the other is trapped in a state of eternal, frozen night. And the seasons? The familiar cycles of spring, summer, autumn, and winter have no meaning here. Because the planet's orbit is so stable and close, there is no axial tilt to drive the changing seasons. The days here aren't 24 hours long. TRAPPIST-1e completes a full rotation on its axis and a full orbit around its star in just about 6 Earth days. A year here, therefore, lasts only 6 days. Imagine that. We could ring in the new year every single week. As for the temperatures there, if it possesses an atmosphere, the average temperature could be quite similar to Earth's. It's neither scorching nor frozen solid. It is a pleasant, temperate world where, if we are lucky, life may have been evolving for billions of years under the light of that red dwarf. TRAPPIST-1e is more than just a planet. It is a mirror, a reminder that in the vastness of the universe, we may not be alone.
I come in peace to your planet. Please show me around your beautiful village.
But just how old is this exotic world? According to astronomical measurements, the TRAPPIST-1 system is quite ancient. The star and its planets are likely 7 to 8 billion years old, nearly twice the age of our own solar system. This vast span of time opens up incredible possibilities. If life requires time to evolve, the TRAPPIST-1e planet has had more than enough time to unfold. Yet the burning question remains: is there water, and is it truly habitable? For now, we are detectives of invisible light. Using the James Webb Space Telescope, we are already analysing the planet's atmospheric spectrum, searching for traces of water vapour or carbon dioxide that could reveal the presence of a stable atmosphere and liquid oceans. In the future, extremely large ground-based telescopes and even more sensitive space observatories will be our key tools, allowing us to map out the details of its atmospheric composition.
Our little village is beautiful, but there is a huge city not far from here. Once I've shown you around our place, I'll show you where to find the city. All right, thank you.
But what about life itself? Science is the language of probabilities. Estimates suggest that the possibility of life emerging on rocky planets orbiting within the habitable zone is not negligible. Some models indicate a 10 to 20% chance of biological activity developing. However, the question of intelligence is an entirely different dimension. Based on statistical models and analogies to the Drake equation, the probability of an intelligent civilization on this specific world is extremely low, perhaps well under 1%. Perhaps we won't find a galactic empire, but something far quieter, a microbial world or simple, adapted vegetation. But regardless of what we find, TRAPPIST-1e teaches us that the universe is teeming with potential, and our greatest adventure is only just beginning. As for when we will get a definitive answer, science is a game of patience. In the coming decade, by the early to mid-2030s, the James Webb Space Telescope and the next generation of ground-based giant telescopes, such as the ELT, will be able to detect biosignatures, such as the simultaneous presence of methane and oxygen. This dual signal could provide almost certain proof that the planet is not just habitable, but inhabited. And while we're on the subject of life, just imagine the possibilities. At 7 to 8 billion years old, TRAPPIST-1e is much older than Earth. Evolution there didn't just begin, it started billions of years before it did here. This immense timescale suggests a biological testing ground where the paths of evolution are deeper and adaptation far more diverse. It is likely that the planet's flora and fauna have achieved a level of complexity and species richness that far exceeds Earth's biodiversity. Under the constant, cool light of a red dwarf star, entirely new survival strategies may have evolved.
Would you like to see our market too? I'd be happy to take you. There are special medicinal herbs there as well. I would love for you to take some home with you to your plant.
Yes, of course, I'm interested.
How do you like our market? Your entire planet is beautiful, and this market is too. I am glad you think so. What are those? A local delicacy.
This is a delicious and medicinal fruit. It has beneficial effects and is healthy.
Oh, then let's try it.
This fruit is special. Please accept it. It extends your life by 300 years. Please take some of it to the people of Earth as a gift too.
I will. Thank you.
Trappist 1e is more than just a planet. It is a time capsule of the universe, one that may finally answer humanity's oldest question: are we alone in this infinite darkness? The answer may very well lie within the technological breakthroughs of the coming decade. All we have to do is
What do you
watch.
think of this dress? You can't go to the city in that strange outfit you're wearing right now.
Well, I don't know how it would look on me.
I think this dress looks really good on you. You finally took off that strange outfit.
Oh, thank you. I'm glad you like it. I'm ready to go check out the city too.
You can see the city in the distance. I hope you'll like it.
It's beautiful even from a distance. Thank you for everything. Thank you for showing me your village. I hope I'll see you again.
Top 5. Number 1, Proxima Centauri b. Life awaits next door, first on the list. The winner. The closest exoplanet to Earth, a prime candidate for extraterrestrial life.
And now we have reached the pinnacle of our journey, the absolute number 1 on our list, and humanity's most promising destination. We don't need to cross the galaxy for this. We don't need to travel thousands of light years, because this planet is right in our own cosmic backyard. It is Proxima Centauri b. It is located just 4.25 light-years away from us. Expressed in kilometers, this is still 40 trillion kilometers. But in astronomical terms, it is right next door. The closest star system to our own Sun, located in the Centaurus constellation. It was discovered in 2016, and it has been the holy grail of space exploration ever since. Proxima Centauri b is a rocky planet with a mass just 17% greater than Earth's. It orbits its star, Proxima Centauri, a red dwarf, in a mere 11 days. Since the star is much smaller and cooler than the Sun, the planet must be very close to it to reside in the habitable zone, and indeed it is. However, because of this proximity, it has a unique characteristic. It is tidally locked. This means the planet always shows the same face to its star, just as the Moon does to Earth. One half of Proxima Centauri b experiences eternal, scorching day, while the other half is locked in eternal, freezing night. Yet life is clever. At the boundary where the two hemispheres meet, in the zone of eternal twilight and sunset, the temperature can balance out perfectly. Here, liquid water could remain stable, and atmospheric currents could provide a pleasant climate. Proxima Centauri b holds the top spot because it is the only habitable zone exoplanet that our generation, or our children's generation, will be able to reach directly. Projects like Breakthrough Starshot already exist, planning to send laser-propelled microprobes to Proxima Centauri. Traveling at 20% the speed of light, these probes would arrive there in just 20 years, sending back the first direct, close-up images of an alien world's surface, its oceans, and perhaps the living creatures that inhabit it. The planet orbits within the habitable zone of a red dwarf star named Proxima Centauri. Although its star is much smaller and cooler than our Sun, Proxima b is so close to it that its surface receives just the right amount of energy for liquid water to exist. But there is a massive catch that completely changes the game. Proxima Centauri is a notoriously active, wicked little star. It regularly produces such gigantic X-ray and UV flares that they could easily strip away the atmosphere of an unprotected planet. For life to exist on this world, Proxima b must possess an extremely powerful global magnetic field and a thick atmosphere to act as a shield protecting the surface. Let's assume this magnetic shield exists and has protected the planet. What would the landscape look like? Since the planet is tidally locked, its star hangs motionless in the sky. On the day side, the horizon is dominated by a gigantic, faint red sun, appearing 3 times larger than our Sun. Although it is a red dwarf star, the planet's thick, Earth-like atmosphere scatters the light to create a familiar, stunning blue sky, forming a beautiful contrast with the reddish star on the horizon. But what is most mind-blowing is the world beneath our feet. Although scientists predict dark red or black vegetation for planets orbiting red dwarfs, evolution on Proxima Centauri b could have used a brilliant trick for survival. To protect against the star's deadly UV flares, the photosynthetic organisms here had to develop a specialized protective pigment structure. According to biologists' models, there is a scenario where the planet's flora, much like Earth's plants, optimally absorbs the blue and red wavelengths of light while reflecting the excess, dangerous radiation. The result? The vibrant, living coastlines and valleys of Proxima Centauri b could be covered in lush, thriving green vegetation. To unlock the secret of Proxima b, we must travel through time. Our own solar system is relatively young, at around 4.5 billion years old. The Proxima Centauri system, however, is substantially older, estimated to be 4.8 billion and potentially closer to 5 or 6 billion years old.
Goodbye, my friend.
In the cosmos, this seemingly small difference changes everything. Consider this. On Earth, mankind emerged a mere few 100,000 years ago, and our technological civilization is scarcely a few centuries old.
Welcome to a city.
If life on Proxima b developed at a similar pace to Earth, their civilization could have a head start of hundreds of millions of years over us. If intelligent life exists there, they have long since surpassed our comprehension. We are not just talking about an advanced species. Based on its age, this society could easily have become an interstellar or even intergalactic civilization. The real question is no longer who they are, but what we have to do with them.
I came in peace to your beautiful planet. Please show me around your wonderful cities. I know the planet Earth and the language you speak as well. Feel free to take off your helmet. We are an intergalactic civilization. Multiple species live on this planet. I will show you around the city.
All right, thank you very much.
I didn't imagine aliens to be like you.
You look very much like humans.
Yes, because you originate from us. We are the same species, but that is a long story.
The cold expanse of interstellar space instantly vanished the moment we understood the truth. We are one and the same species, separated only by time and the galaxy. For millennia, humanity gazed at the night sky, searching for answers to our origins, while our creators were waiting for us all along, in the light of the closest star. We have come home. We are the direct descendants of the civilization of Proxima b. This discovery rewrites our entire history and our understanding of evolution. We are not alone in the cosmos. We are the youngest children of a vast intergalactic family.
Then, we must not delay.
Because our past is the key to our future, and on Proxima b, we have found ourselves. The cold expanse of interstellar space instantly vanished the moment we understood the truth. We are one and the same species, separated only by time and the galaxy. For millennia, humanity gazed at the night sky, searching for answers to our origins, while our creators were waiting for us all along, in the light of the closest star. We have come home. We are the direct descendants of the civilization of Proxima b. This discovery rewrites our entire history and our understanding of evolution. We are not alone in the cosmos. We are the youngest children of a vast intergalactic family. Because our past is the key to our future, and on Proxima b, we have found ourselves.
This story is yours now too. If you are ready for more people to know the truth, share this footage and write your thoughts in the comments. And tell me, do you think Earth is ready yet? Would you welcome me into your world?